So, hi everyone, I am Neelav Bhatiya and I appeared for my JEE examination in the year of 2020, wherein I secured a rank of 1755. In the previous session, which was the first session for this chapter, we discussed its first exercise. Preceding that, we even had a look at some of the basic concepts that are involved in building up, which served as the building blocks for this chapter. And we saw some very trivial formulas here and there. And pertaining to that, we solved one exercise as well, wherein we applied the formulas that we learned, right? So the first exercise of this chapter was over. We also had some time spared with us, so we uh, took a look at the first three questions of the second exercise as well. Now we are going to cover the remaining part of the exercise. As we move on, as we proceed, there might be some new formulas that will be introduced to us, and I'll be sure to bring them up as and when we encounter them. And yeah, so that is all. Now let us get into the session. So as you can see, we arrived at the exercise 8.2 in our previous session, and we were also able to see the first three questions of this particular exercise. Now we are going to start with the remaining questions, and we are going to see if we can finish off this exercise in this session, right? So the exercise that we're going to be attempting today is exercise 8.2. And in exercise 8.2, we are going to be starting with not the first question, but the fourth question, because we saw the first three questions previously, right? Now, let us take a look at the fourth question. The fourth term of a GPA is square of its second term, and the first term is -3. Determine its seventh term. Now, before we actually attempt to solve this question, let us kind of jot down everything that has been given to us, right? So the first term, let us denote that by A, as we do very trivially and very often in GP, we denote the first term as A. So A, which is going to be the first term, has been given to us as -3. Then we have that the fourth term of the GP is square of its second term. Now, if the first term is A, then the nth term of this particular GP would be denoted by A r raised to the power n-1. Let us say the common ratio of this GP is r, right? And we know the nth term is denoted by A r raised to the power n-1. So the fourth term is going to be A r raised to the power 3, correct? And the second term is going to be A r, correct? Because 4 minus 1 is equal to 3 right here, and 2 minus 1 is equal to 1. So r raised to the power 1, which is nothing but r itself, right? We have been given that the fourth term is the second term. The fourth term of GP is square of its second term. So when we square this second term, we are going to arrive at the fourth term, right? So that is what we are going to do. We are going to square this up and see what we come at, right? Drop this off. So what we have here, the fourth term has been given to us as A r to the power 3. So A r to the power 3 is equal to A r the whole squared, correct? This is what I arrived at. After this, we can square the second side. So what we do is we square both the terms inside the bracket. We get A square, r square, correct? A gets cancelled, r gets cancelled. So we have r equal to A, correct? We have what we have done is we have divided both the sides by A. So A gets cancelled from the LHS, and we have divided both the sides by r squared. So r square gets cancelled from the RHS. So the final formula that we arrive at is r equal to A. And A has already been specified to us as -3, correct? So we have the common ratio of this particular GP also as -3. So r is equal to -3. Now what do we have to do? We now have to determine what is going to be its seventh term. As we have previously seen, the nth term of any GP is going to be of this form, right? And nth term of the GP is going to be A r to the power n-1, correct? So the seventh term of this GP is coincidentally going to be r of A r to the power 7 minus 1, which is nothing but A r to the power 6, correct? So we now have the value of A, which is minus 3. We now have the value of R also, which is also going to be minus 3. So plugging the values here into the equation, you get minus 3 into minus 3 raised to the power 6. You can add these powers up, and that is going to give you minus 3 raised to the power 7. When you finally solve this, when you finally calculate this, the final answer that you're going to arrive at is minus 2187. And that is going to be your answer. Minus 2187 is the seventh term of the GP whose first term is denoted by, whose first term is minus 3. And the common ratio when you find out is also going to be minus 3. Correct? And that was the fourth question for you all. Moving on to the fifth question of this particular exercise, we now have question number 5, right? In question number 5, we have to determine which term of the following sequences, and then we have been given 3 sequences, and in that sequences we have been given a term as well, and we need to find out what number term is that going to be, right? So for the first sequence we have 2, then we have 2 root 2, then we have 4, and so on and so forth. And the nth term has been given to us as 128. Correct? Now we have been given the sequence as 2 root 2, 4, and so on and so forth. As you can very obviously see, the common ratio between each of these terms is going to be root 2, because as in when you multiply root 2 to any of the term, you're going to get the next term, right? So this is a very trivial GP which you can very easily observe, and which has a common ratio of root 2. Let us kind of verify that mathematically, and then solve the question, right? So the first term in this GP is A is equal to 2, correct? Because that is the first term. Now for finding R, what we simply have to do is we need to divide the second term by the first term, and that is going to give us the common ratio, correct? So we have 2 root 2 divided by 2. 2 and 2 gets cancelled, and the common ratio that we find out is root 2, correct? So we have A equals to 2, R equals to root 2, and as we have seen previously, the nth term of any GP will be denoted by A r to the power n minus 1. Correct? That is how we are going to find out the value of n. That is how we are going to find out the value of how we are going to find out what number term 128 is going to be. Right? Now, doing that, we have, so what we are going to do is we are going to write A r to the power n minus 1, equate that to 128 to solve for the nth term. Right? Now, let us plug in the values of A, R, and that is how we are going to find the value of n. Correct? So we have A is equal to 2, R is equal to root 2 raised to the power n minus 1, equating to 128. Now you can divide both the sides by 2. Here you will have 64, and here you will have root 2 power n minus 1. Correct? Moving on, proceeding further, we now have root 2 to the power n minus 1 equals to 64. Let us kind of convert RHS and express that as a power of root 2, right? So we now have root 2 n raised to the power n minus 1 as 64 can be expressed as 2 raised to the power 6. Correct? But we need to express it in the terms of root 2. So as you know, root 2 is nothing but 2 raised to the power half. Correct? So let us convert 2 as root 2 raised to the power 2 and see what we get. Right? So let's do this. Express that in terms of root 2. So is 2, and that is raised to the power 6. Correct? Can you understand this? Because 2 can be expressed as root 2 raised to the power 2. Correct? Square of root 2 is nothing but 2. And we have already seen how 64 is 2 raised to the power 6. Correct? So that is all I've done. I've converted both sides. So now we can finally equate the powers. As you know, when power is raised to another power, the powers get multiplied. So in the RHS, we now have root 2 raised to the power n minus 1 equating to root 2 raised to the power 12. Correct? As you see, now both the LHS and RHS have the same base. Now we can finally equate the powers. So we have n minus 1 equating to 12 and n being equal to 13. So this is the 13th term of this particular sequence of this particular GP. Correct? Moving on to the second part of this question. Question number 5, we are going to move to the B part, right? In the B part, we have root 3, 3, 3 root 3, and the term that we are going to find out is 729. Correct? So the first term of the sequence is root 3. Correct? The common ratio R can be found out by dividing the second term by first term. This is a very common trick that you all should remember. Whenever you see a sequence in the form of a GP, if you want to find out the common ratio, do nothing. Just divide the second term by the first term, and that is how you're going to arrive at the common ratio, right? Second term is 3 divided by root 3, and that is nothing but root 3. So we have the first term as root 3. The common ratio is also root 3, and let us see what we get then, right? So the nth term is 729, and we need to find out the value of n, right? So the nth term could be denoted by, me rub this off. The nth term could be denoted by a r to the power n minus 1, and that equates to 729, right? So the first term is root 3. The common ratio is also root 3. The common ratio is also root 3 to the power n minus 1. And on the RHS, you have 729. Correct? Now, root 3 into root 3 power n minus 1, the powers can now be added. So on the LHS, we have root 3 raised to the power n. And on the RHS, let us express 729 as in the terms of root 3 and see what we get, right? So 729 is nothing but 3 raised to the power 6. And again, 3 could be now expressed as root 3 to root 3 squared. So let us do that. We have this equating to then root 3 ka whole square, and that entire raised to the power 6 would equate to 729, right? I have done nothing. I have just done what I had done in the first part of the question. I have expressed root 3 as root 3, as I had done previously. I had expressed 2 as something raised to the power root 2, right? So I've done similarly here as well. So what we here now have is root 3 raised to the power n, and here you see that powers raised to the power are going to get multiplied. So on the RHS, what you are left with is root 3 raised to the power 12. Now, as both the bases are same, you can compare the powers. So you have n equal to 12, and that is going to be the 12th term of your sequence. Correct? Now, moving on to the last part of this exercise. In part number C, you have been given that the first term is 1 by 3, the second term is 1 by 9, the third term is 1 by 27, and you have been asked to find out what term is going to be 1 by 19683. Correct? So that is what you are going to find out here. And let us write down what the information that has been given to us. So A has been given to us as 1 by 3. The common ratio R can be found out by dividing the second term by first term. Doing that, we have 1 by 9 divided by 1 by 3. And now, doing that, the common ratio that we find out is 1 by 3. Correct? Moving on. So the common ratio is 1 by 3, and the first term is also 1 by 3. The nth term of this sequence has been given to us as 19683. So solving that, we have nth term can be expressed as a r raised to the power n minus 1, and that has been given to us as 1 upon 19683. Correct. Moving on, what do we have then? Let us write what the first term is and the common ratio is, and let us solve accordingly, right? So the first term we found out is 1 by 3. The common ratio is also 1 by 3, and that is raised to the power n minus 1. Correct. 19683 is nothing but 3 raised to the power 9. So you can express this as 1 upon 3 raised to the power 9. Right? Powers get added up when they're multiplied. So on the LHS, what you're now going to have is 1 by 3 raised to the power n, because n minus 1 plus 1 is going to be n. And on the RHS, what you're going to now have is, I can raise this entire term by 9, because 1 raised to the power 9 is nothing but 1. So I can denote this right here as this, and that won't change anything, right? So as now based on both the sides are same, I can compare the powers. N is now going to be 9, right? So we have solved this exercise. It was plentiful because we had 3 subparts to solve, but yeah, it was a very trivial exercise for us, and we were able to do it, right? Moving on. Moving on to question number 6. For what values of x the numbers minus 2 by 7, x, and minus 7 by 2 are in a GP, right? So we have been said that minus 2 by 7, x, and minus 7 by 2 are going to be in a GP, right? If these terms are going to be in the GP, can I say that the common ratio of these terms could be expressed as second term divided by first term, which is nothing but x divided by minus 2 by 7, which when you simplify is 7x minus 7x by 2. Correct. Is this fairly simple, fairly straightforward to understand? Correct. Then we have also been said that minus 7 by 2 and x are also going to be in G. We have been said that these 3 terms are going to be G, right? So can I write the common ratio again as minus 7 by 2 divided by x, which is nothing but the third term divided by the second term, and denote that as the common ratio? Can I do that? When I do that, what I obtain is the common ratio as minus 7 by 2x. Correct. So the common ratio is also minus 7x by 2, and the common ratio is also minus 7 by 2x. Now when you equate both of these, you're going to find out the value of x, right? So I'm just going to equate the common ratios, because I now have 2 different formulas for the common ratio. So minus 7x by 2 is equal to minus 7 2x, right? Minus gets cancelled, 7 gets cancelled, 2 and 2 gets cancelled. What I finally have is 1x equal to 1 by x. Correct. Solving this further, let us multiply both sides by x. What you get is x squared equals to 1, and when you solve this, you get x equals to plus minus 1. So there are 2 values which are x equals to 1 and x equals to minus 1, for which this is going to be in a GP, right? These 3 terms are going to be in a GP. There are 2 values of x for which these 3 terms are going to form a GP. Correct. Moving on to the question number 7. Question number 7 says that find the sum to 20 terms in geometric progression 0.15, 0.015, 0.0015, and we need to find the sum of this GP up to 20 terms, right? as you very well know, the sum, up till nth term in a GP is going to be a 1 minus r raised to the power n upon 1 minus r. Right? This is a very well-known formula, and if you have read the theory, like read any bit of theory, you will be very you'll be aware about this particular formula. And if you are not aware of this formula, I would urge you all to go and kind of read the theory that precedes these exercises, and that is how you're going to be familiar with the derivation and how we arrive at this particular formula, right? To calculate the sum up till the 28th term, I would then want n to be 20, right? So the sum of up until the 20th term would equate a r raised to the power 20 upon 1 minus r, right? So this is going to be my sum up till the 20th term. Now we have a as 0.15, right? Because the sequence that has been given to us is 0.15, 0.015, 0.0015, and so on and so forth, right? So the first term, a, is going to be 0.15, right? Moving on, the common ratio for this GP is going to be, as we had previously discussed, we divide the second term by the first term, and when you do that, what we obtain is 0.015 divided by 0.15. So the common ratio is nothing but 0.1. Correct. Now, having said that, we are now going to plug in these values into the equation, into the formula that we had obtained for the sum for the sum of the 28th term, and we're going to find out what that is going to be, right? So S of 20 is going to be, as we had previously seen, S of 20 is nothing but a 1 minus r raised to the power 20 upon 1 minus r. A has been given to us as 0.15. We have r 0.1 raised to the power 20 divided by 1 minus 0.1. Simplifying this, we get 0.15 upon 0.9, 1 minus 0.1 raised to the power 20. As you can very well see, this is nothing but 0.9 is nothing but 0.15 into 6. So I can cancel these out. I can say 1 and I can say 6 here. So the final sum that I'm left with is 1 minus 0.1 raised to the power 20 divided by 6. That is going to be my sum up until the 20th term. Now, if you want, you can find out and calculate what this value is going to be, but I don't see any point in doing that. You can leave the answer here, and that is going to be fine as well, because this is nothing but some trivial calculation which could be done using a calculator if you want. But yeah, this is going to be your answer. Moving on to the 8th question. In the 8th question, you have find the sum to n terms in the geometric progression root 7, root 21, 3 root 7, and so on and so forth, right? So first, let us see what is going to be the first term of the GP. That is very obvious to us all. That is root 7. Let us find out the common ratio of this GP. Common ratio, again, second term divided by first term, and that is going to be nothing but root 21 divided by root 7, and that is nothing but root 3. We have been asked to find the sum up until the 20th term, and how are we going to do that? We are just going to plug in the values of root 7 and root 3 into the SN formula, and the SN formula is nothing but a 1 minus r raised to the power n 1 minus r, correct? And pertaining that, we have the first term of the GP as 1 minus r raised to the power n 1 minus r. Now, if you want, you can find out the common ratio of this GP. Common ratio, again, second term divided by first term, and that is going to be nothing but root 7 divided by root 3. We have been asked to find the sum up until the 20th term, and how are we going to do that? We are just going to plug in the values of root 7 and root 3 into the SN formula, and the SN formula is nothing but a 1 minus r raised to the power n 1 minus r, correct? And pertaining that, we have the root 7, right? The common ratio is nothing but r raised to the power, and let us write the values of r now. We have common ratio as 3 raised to the power n. We have, and in the denominator we have 1 minus r, and r is again nothing but 1 minus root 3. Correct. Now, what do I now have is I have some part in the denominator which is non-rational. So to kind of rationalize this, what I'm going to do is I'm going to multiply this by 1 plus root 3 and this by 1 plus root 3. Correct. Now, what you then get is, so in the numerator, what you now have is numerator. What you now have is root 7 stays the root 7. You get it multiplied by 1 plus root 3. Here you have 1 minus raised to the power n. Correct. In the denominator, what you now have is 1 square minus root 3's whole square. Right. Now, solving this, you get negative comes up here, 1 plus root 3. And in the bracket, now you have 1 minus. Let us express root 3 as 3 raised to the power half. So this now becomes 3n by 2. Correct. To just kind of simplify our doings, and this becomes 2, right? I've already written the negative sign that comes from 1 being 3 being subtracted from 1. Now let us propagate this negative sign into the bracket right here, and when you do that, the final answer that you're going to obtain is root 7 multiplied by root 3 plus 1 divided by 2, 3 raised to the power n by 2 minus 1, and this is going to be your sum for the nth term. Correct. So that was the 8th question. Moving on to the 9th question. In the 9th question, you have the sequence as 1 minus a square minus a cube, and you want to find its sum until the nth term. Right. Now, you have this as the nth term, and you have this as GP, and you want to find out the sum until the nth term. Interestingly, we have been also said that a is not equal to minus 1. Now, why is this important? Why is this of concern here? Because if you see the formula for the SNth, which represents the sum until the nth term, then you find out that in the denominator you have 1 minus r, and if r, or which is in case a here, equates to minus 1, then that is going to be of concern to us. That is not something that we will like, right? Because if a is equal to minus 1, then 1 minus r is 0. And if you have 0 in the denominator, that is going to cause you many problems, right? So just a side note there, nothing of importance, but just make sure a is not equal to minus 1. That has been given to us, right? Now, in this particular GP, you have the first term. Let us denote that by a as 1, right? And the r is going to be nothing but second term divided by first term. Again, the common ratio is minus a. Correct. So Sn is nothing but a 1 minus r raised to the power n upon 1 minus r. Plugging in the values of A as being 1 and the common ratio as being minus A, the Sn that you're going to get is 1 minus A raised to the power n upon 1 minus A. Right. Then what you have is 1 minus A raised to the power n, and you can omit this one because that is not going to change your answer, and the denominator you have 1 plus A. That is going to be your Sn. Correct. Very easy, very simple for us to understand. And yeah, that was all. Right. Moving on to the 10th question of this exercise. For the 10th question, you have the sequence as x cube, x raised to the power 5, x raised to the power 7, up until, and you want to find out the sum of this particular GP up until n terms. Right. Here you have been said that x cannot equal plus minus 1. And why is that? As I had previously explained, that if x, or let's say a, equals plus minus 1, then that is going to cause us a lot of problems in denominator of the SN term, right? Because that is going to be 1 minus r. And if that equals plus minus 1, then that could lead to the denominator going to 0. This is not something that we want, right? So the first term of this GP is expressed as a equals x cube, correct? And common ratio is nothing but second term divided by first term. That is nothing but x raised to the power 5 divided by x cube. That's going to be x square, right? So the common ratio is x square. The first term is x cube. Plugging these values into the SNX formula, Sn equals a 1 minus r raised to the power n upon 1 minus r. Using the values of x, a is equal to x cube and r is equal to x square, what I finally arrive at is Sn equals a 1 minus r is nothing but x square. So I have x raised to the power 2n upon 1 minus r is x square again. We forgot to substitute a as x cube. Let us do that in the next step. So the Sn, the final answer is going to be a, let us substitute a by x cube, and we have 1 minus x raised to the power 2n. Denominator we have 1 minus x square. Correct. So that was our answer, and yeah, that is how it's going to be. Correct. Makes sense. So this was the 10th question. Moving on to the 11th question, which is going to be something different. Up until the last 4 questions we solved, that were of the same type, and this is going to be something else. Right. Moving on. Up until k equals 11 for 2 plus 3 raised to the power k is going to be, right? So what I'm now going to do is I'm now going to kind of write down what the first few terms of this sequence are going to be, and that is how we are going to observe a pattern and solve this question, right? So the first term, plug in the value of k equals to 1. The first term is nothing but 2 plus 5, right? 2 plus 3. The second term is going to be 2 plus 9. The third term is going to be 2 plus 27, and so on and so forth. As you see, 2 is repeating it in all terms, right? So when you do that, you have 2, when you separate these terms, you have 2 added up 11 times. So the first term of this sequence addition is going to be 2 plus 2 plus 2 plus 2 and so on and so forth until 11 terms, right? I have separated out 2 plus 3 raised to the power k, and that is how I'm going to approach this question. So the first term of S11 is going to be 2 added up 11 times. Very trivial for us to see, because 2 plus 3, then we have 2 plus 9, then we have 2 plus 27 and so on and so forth. 2 is repeating itself across every term, and that is going to be the case for all 11 terms. So we have 2 added up until 11 terms, and the second term is going to be 3 plus 9 plus 27 up until 11 terms. So in the second term you have 3 plus 9 plus 27, and that also you have until 11 terms, right? See, look at the fact that this second term is compressed of a GP, right? With the first term as 3, and the common ratio, which is 9 divided by 3, also has 3, right? So finally, S11 could now be expressed as 2 into 11, because 2 has been added up 11 times, plus S11 for the GP. A is equal to 3 and R is also equal to 3. Let us solve this, and that is how we are going to arrive at our answer, right? So here you have 2 into 11, and that is nothing but 22. And for the first 11 terms of the GP, with the first term as 3 and the common ratio as also 3, you have A 1 minus R raised to the power n upon 1 minus R. Now, because the common ratio is greater than 3, I'm going to reverse the sign in the numerator and denominator as well. So finally, when I'm going to write this as 22 plus the first term has been given to us as 3, and I have 1 minus R here. So I'm going to subtract I'm going to do R minus 1. I have 2 in the denominator, and the numerator I have the common ratio is also equal to 3, and we need to find up until the 11th term. So 3 raised to the power 11 minus 1, and that is going to be your final answer, right? So we have done nothing but in the sequence that has been given to us, we separated the first term and the second term. And the first term we saw formed just a series of addition of 2 up until 11 terms, and the second represented the GP, right? So that is how we solved for it. And but doing that, we found out what the answer is. Moving on to the 12th question. In question number 12, we have been said the sum of the first 3 terms of a GP is 39 by 10, and their product is 1, right? So whenever you have questions of these accords, you might be inclined to take the first 3 terms of the GP as AR square, right? If you assume, you might assume that the first 3 terms of the GP are AR, AR and AR square. But this is not going to be very helpful for you all, because you have the 3 terms. Then you should take the terms in accord such that the RH, the common ratio, gets cancelled, and you find out the one quantity of the term very quickly, right? So if I were to choose the first 3 terms when their product has been given to us, what I would do is I would assume the 3 terms to be like this: AR, A, and AR, right? What this now does is, when these 3 terms are multiplied, R gets cancelled, and what I'm only left with is an equation in terms of A. So I will easily be able to solve for A, and that is how I'm going to be able to find out the value of A, and subsequently I'm going to be able to find out the value of R as well, right? So that is how it's done, and that is what helps us all here. So let us assume the first three terms of the GP as going to be A by R, A and AR. Mind you, the common ratio is still going to be R, but I've just assumed the terms such that R gets cancelled out. We have been then told that the product is 1. So let us multiply these three terms by let's multiply these three terms and find out what and equate that to 1, right? So I have A by R into A into AR, right? R and R gets cancelled, and on the RHS I have 1. So I have A cube equating to 1. When A cube equals to 1, I know for a fact that I have A equals to 1, right? So the first term of the GP is going to be, or the second term in this case is going to be 1, right? Now I have been told that the first three terms add up to 39 by 10, right? So I will do that. So let us plug in the values of A as equal to 1 in the first three terms and add them up and equate that to 39 by 12. So on the RHS, I would have 1 by R plus 1 plus R as equals to 39 by 10. Multiply both the LHS and RHS by R because we don't want R to be in the denominator. So what I now get is 1 plus R plus R square equals to 39 R by 10. Multiplying both sides by 10, what I now get is 10 plus 10R plus 10R square equals to 39R. Taking the 39R onto the LHS, you now get 10R square minus 29R plus 10 equals to 0. Now, to find out the root of this equation, 100 can be expressed as 25 into 4. So doing that, let us like divide minus 29R into minus 25R and minus 4R, right? So what you obtain is minus 25R minus 4R plus 10 equals to 0, right? Taking out 5R common actually. So you have 5R and what is left with is 2R minus 5. Similarly, we get minus 2 common here. Minus 2 common here. So you get 2R minus 5, right? We have separated these two things out and you now have 5R minus 2 and the another root is 2R minus 5 as being equal to 0. So R is either equal to 2 by 5 or R is either equal to 5 by 2, right? Therefore, the first three terms of the GP. So let us plug in the values of R as 2 by 5 and 5 by 2 and see if that changes our answer in any ways, right? So the first three terms I have are 1 by R and R. 1 by R, 1 and R, right? So if I use the value of R equals to 2 by 5, my first term is going to be 1 upon 2 by 5. Second term is going to be 1. The third term is going to be 2 by 5. So ultimately, the first three terms are going to be 5 by 2, 1 or 2 by 5. Correct. If I use the value of R equals to 5 by 2, let us see what I then get. I have R equals to 5 by 2, 1 and 5 by 2. Correct. In that case, my terms are 2 by 5, 1 and 5 by 2. In either case, my three terms are going to be the same. So irrespective of the value of R that I choose, the first three terms are going to be the same. And that is what I wanted to show you all here, right? So the first three terms of the GP are going to be 2 by 5, 1 and 5 by 2. The common ratio is either 5 by 2 or 2 by 5 depending upon what you choose. And the first term of the A is going to be 1, right? Moving on to the 13th question. Moving on to the question number 13th. Right. In the question number 13, we have been given how many terms of the GP 3, 3 square and 3 cube are needed to give the sum 320. So the sum, let's denote that by S, has been given to us as 120. Sn has been given to us as 120. The sequence is 3, 3 square, 3 cubed. So the first term is 3. The common ratio is 3 square divided by 3. And that is also going to give you 3 right here. So the first term is 3. Common ratio is also 3. Sn is given to us as 120. And we need to find out the value of n, or the number of terms that we need for this being equal to the sum that has been given to us, right? So Sn is nothing but a r raised to the power n. And why I have done r raised to the power n minus 1? Because r, the common ratio here, is greater than 1. So it is better to express this in this form. And I have r minus 1, right? So equating this to 120 and solving for n, what you finally get is a, and denote that by 3. R is also 3. So 3 raised to the power 1 minus 3 raised to the power n minus 1. In the denominator, you have 3 minus 1. And this entire term is equals to 120, right? Multiplying both sides by 2, you get 3 into 3 raised to the power n minus 1, and you get 240 over this side. 3 and 3 gets cancelled. This becomes 80. So you have 3 raised to the power n minus 1 as being equal to 80. Adding 1 up on both sides, you have 3 raised to the power n equals to 81. When you solve for n, the final answer that you're going to arrive at is 3 raised to the power n equal to 3 raised to the power 4, because 81 is nothing but 9 squared and 9 squared is nothing but 3 squared. So 2 into 2, that gives us 4. So 81 can be expressed as 3 raised to the power 4. As both these bases are going to be same, I can compare the powers now. So n is going to be 4. So you need the sum of the first 4 terms in order to get the sum of the GP to 120. Correct? That was a solution for the 13th question. Moving on to the 14th question. Let us rub these things off and move on to the next question. In the 14th question, you have the sum of first 3 terms of the GP is 16 and the sum of next 3 terms is 128. Determine the first term, the common ratio, and the sum to n terms of the GP. Right. So we have been given to us that the first 3 terms, the sum of the first 3 terms is 16 and the next 3 terms is 120. In this case, earlier when the product had been given to us, we assumed the 3 terms of the GP in the form of a by r, a and ar, so that it facilitates us to cancel out r while solving for product, right? And that is how we find the value of a very simply. But here, product has not been mentioned. So it does not make any sense for us to assume the first 3 terms as going to be a by r, a and ar, right? So I'm just going to assume 3 basic terms. Let us assume that AP or GP is going to be of the form AR square, AR square, and so on and so forth, right? This is going to be my GP. So the first 3 terms, sum of the first 3 terms, let us denote that by S of 3, is going to be nothing but A plus AR plus AR square. And that has been given to us as 16, right? Now what I can do is I can take out A common from these 3 terms and express 16 as A 1 plus R square, right? Now the sum of the next 3 terms, let us denote that by S double dash of 3, right? I cannot say that is S of 6 because the first 3 terms are not considered, right? So then the sum of the next 3 terms is going to be AR cube plus A raised to the power R raised to the power 4 plus power 5, right? This is the sum for the next 3 terms, right? Here also I can take out a r square common, and I would then have 1 plus r square right here. In the LHS, we have been given that the sum of next three terms is equating to 128, right? So I have this equation. Let us denote this by second and let us denote this by 1. Dividing 2 by 1, what we finally get is 128 divided by 16 equals AR square 1 plus R square, and the denominator you have 1 into A plus R square, right? So you can cancel this entire term out. You can cancel R and R. Here 16 divided by this is R cube. So this is R cube as well, because you take A raised to the power A into R raised to the power 3 as common. So 128 divided by 16 goes 8 times. So R cube is nothing but 8, right? And when you solve for R, the final value that you get is 2, right? So the R has been given to you now as 2. Now you just need to solve for A. So the sum of first three terms is going to be A 1 plus R square equating to 16, and therefore the first term that you're going to get is A to 1 plus R is going to be 2, R square is going to be 4 is equal to 16, right? So A into 7 is equal to 16. First term of this GP is going to be 16 by 7, right? So the first term has been found out, the common ratio has been found out, and we now need to find out the sum of the GP up until the next n terms, and that is what we are going to do. So Sn would consecutively be equal to A r raised to the power n minus r raised to the power n minus 1 upon r minus 1. Substituting the values of A and R here, so you have 16 by 7. In the brackets, you have 2 raised to the power n minus 1. And in the denominator, what you then have is 2 minus 1, and that is nothing but 1 itself. So the final answer is 16 upon 7, 2 raised to the power n minus 1. That is going to be your Sn for this particular GP, right? That was nothing but the 14th question, and we were able to solve it. We were able to find out the common ratio. We were able to find out the first term of the GP, and consecutively, we were able to derive a formula for the SN term of the GP, right? Moving on to question number 15. In question number 15, we have given a GP with A is equal to 729, and the seventh term as being equal to seventh term as being equal to 64. Determine S7, right? So in question number 15, we have a GP with A equals to, just a moment, A equals to 729, and you have the seventh term as being equal to 64. So the nth term of the GP could be expressed as, so the seventh term could be expressed as A r raised to the power 6, and seventh term has been given to us as 64. A has been given to us as 729. We need to solve for r raised to the power 6. So when you do that, you have r raised to the power 6 as being equal to 64 divided by 729. And this is nothing but r raised to the power 6, and 64 is nothing but 2 raised to the power 6. Similarly, 729 is nothing but 3 raised to the power 6, correct? And correct. So we can now write this as 2 by 3 raised to the power 6 equals to r raised to the power 6. When you solve for that, when you solve for real roots of this equation, you finally have r as being equals to 2 by 3. The common ratio that we now have is r equals to 2 by 3, and we now have to determine what s of 7 is going to be. And so s of 7 is going to be a 1 minus r raised to the power n upon 1 minus r. Correct. So plugging in the values of a and r into this equation, you have a as being equals to 729. In the brackets, you have 1, 2 raised to the power 3 up until n. 2 raised to the 2 divided by 3 raised to the power n, and in the denominator you have 1 minus 2 by 3. So that is going to be nothing but 1 by 3, and 3 gets multiplied up into the numerator. So you have 729 into 3, and in the brackets you have 1 minus 2 raised to the power 2 by 3 raised to the power 7. Right. So 729 is nothing but 3 power 7, 3 power 6. So you can write this as 3 power 6 into 3, and you can write this as 3 power 7 minus 3, 2 power 7 divided by 3 power 7, right? So 3 power 7 and 3 power 7 gets cancelled from here. What we finally left with is 3 power 7 minus 2 power 7, and as we all know, 3 power 7 is nothing but 2187, and 2 power 7 is nothing but 128. So plugging the values here, 2187 minus 128, and when you solve that, you get 2059. Right. So that is going to be your S7, which represent the sum up until the 7th term. And when you have the values of A and R, it's very trivial for you to find out S7. And as you see, we practically skimmed through this question, and we are able to do so because we have already been given the values of A and R, right? So when you do have that, it's very easy to plug in the values and find out what the answer is going to be, right? Moving on to the 16th question, and I believe, this had become unresponsive because we are not scrolled down for a while. So I do believe we have the 16th question for us to solve now, and we'll be able to do so momentarily. Right. Let me drop these things off. Let's do that. Scroll up. Drop this off as well. For the 16th question, we have been given find a GP for which the sum of first two terms is going to be for the first two terms is -4, and the fifth term is 4 times the third term, right? So we have been given the sum of first two terms as being equal to 4. I mean, or being equals to -4. So we have S of 2 as being equals to -4, and we have the fifth term as equals to 4 times the third term. Correct. So that is what we have. So S of 2 would be represented as A 1 minus R raised to power n, that is going to be 2 upon 1 minus R, right? And this entire equation is nothing but R, -4. So equating this to -4, you have A 1 minus R square into 1 minus R, right? For the fourth term, you have for the first, you also have this particular equation to solve for. You have fifth term as being equal to 4 times the third term. So fifth term could be denoted by A raised to the power 4, and this could be written as 4 into A raised to the power 2, right? So cancelling this out, you get r square equals to 4, and when you solve for that, you have r being equals to plus minus 2, right? Using the values here, let us solve for r. First solve for r equals to 2, and subsequently we are going to be solving for r equals minus 2, right? So for r equals to 2, we have minus 4 equals to a, 1 minus r square is now going to be 4, and in the denominator you have 1 minus 2, so that is going to be minus 1, right? So multiply that, what you finally get is minus 4 equals 3a, correct? What I've done is I've multiplied both sides by negative 1, or I've done nothing. I've just cancelled minus 1 off and reverse the sign of the numerator from here to here. So I have 3a equal to minus 4, and a would then be minus 4 by 3, right? For r equals to minus 2, what do we have here? You would then have minus 4 equals to a into 1 minus 4, correct? And the denominator you would have 1 minus 2, right? So you would have minus 4 equals to a minus 3 divided by 3. This gets cancelled out. A is equals to 4. So either a is equals to 4 or a is equals to minus 3. So either your GP is of the form minus 4 by 3 minus 8 by 3 minus 16 by 3, and so on and so forth, when r is equal to 2, or your GP is of the form 4 minus 8 16 minus 32, and so on and so forth. So either this is going to be a GP or this is going to be a GP. And why is that? Why do we have multiple solutions? Because the conditions that we have been given are of the form that multiple things could satisfy that. So if you add minus 4 by 3 and minus 8 by 3, you are going to get minus 4 here. And if you add 4 and minus 8, you are also going to get minus 4. So both of these GPs are going to satisfy your condition, and that is why you have two answers as being solutions to this particular question, right? So that was the 16th question for you guys. We have been able to complete 16 questions of this exercise, and in the next session, we are going to take the remaining questions of this exercise, and we are going to be able to solve this entire exercise. Meanwhile, I would ask and urge you guys to revise all the formulas once. So as in when you proceed with this exercise, it's not going to be hard for you guys to find out what the solutions are, right? So that is all we have for today. And moving further, we are going to solve all the remaining questions of this exercise, and we are going to take a look at the remaining exercise as well, right? So yeah, that has been all, and thank you for paying attention.